Okay, so in this video, we're going to discuss exercise 6-62. We're not going to discuss this anymore in class, but I like this problem because it integrates what you have learned so far when or how to basically determine the products of an exchange reaction, meaning a reaction in which you either form or not precipitate, an insoluble precipitate. It also is a good recall here of how to do limiting and excess reagents. Okay, so I like really this problem a lot. Okay, so you're given here that you have silver chloride being produced from the reaction between silver nitrate and calcium chloride. Now, this is a limiting excess reagent problem just because you're given here two number of moles, which you can derive from the volume and the molarity for silver nitrate, and you also have one for calcium chloride. Okay, so whatever there will produce the lesser amount of silver chloride should be the limiting reagent. Okay, but first, with all of this, let's first write the balanced equation. So the balanced equation should be silver nitrate. Okay, it's the formula for silver nitrate, and then plus calcium chloride, aqueous, okay, which will give you silver chloride solid, okay, that's not going to be soluble in water, and then add that with the calcium nitrate. Okay, I have to say this is actually one of the ways to solve this problem, by the way. So here we're using the complete molecular equation. Okay, there's a way in which you can solve this using the net ionic equation directly, but we're just going to talk about it later at the end of the video. Okay, this equation's not yet balanced, so we're going to put here a 2, and you're going to put a 2 here. Again, equations like exchange reactions are very easy to balance. Go to my video where I'm talking about stoichiometry examples. Okay, so let us look at if silver nitrate was limiting. Okay, is limiting. Now, again, we can calculate the number of moles from the volume and the concentration of silver nitrate in solution. So that will be what we're actually trying to calculate here, by the way, is the mass of silver chloride if silver nitrate again is limiting. So that's going to be 0.1000 liters. That's just the 100.0 ml, okay, of silver nitrate. Then multiply that with 0.20 moles of silver nitrate. Okay, oops, sorry for the stray marks. And then divided by liters. Okay, then after that we have to convert, notice here that liters are gonna get canceled out. Then after that we have to convert that into moles of silver chloride. So that will be 2 moles of silver nitrate. Okay, and then here we put 2 moles of silver chloride. Okay, these terms will cancel out as well. Okay, and then finally, to arrive at grams of silver chloride, use the molar mass of silver chloride. 1 mole of silver chloride is equal to 143.4 grams of HECl. Okay, again, terms will cancel out, and this should give you 2.9 grams of HECl silver chloride produced if and only if, again, silver nitrate is the limiting reagent. We do exactly the same for calcium chloride. So if calcium chloride is limiting, okay, then information we have from calcium chloride is you also have a 100 ml volume of solution, so 0.1000 liters, but here the concentration is 0.15 moles of calcium chloride, okay, per liter. Okay, and then again we need to convert this from moles of calcium chloride into By the way, this is a mass of AgCl, the one we're trying to calculate here. Okay, and then convert that to moles of AgCl. So this is 1 mole of calcium chloride, 2 moles of silver chloride, and then 1 mole of silver chloride is equal to 143.4 grams of silver chloride. Now this will give you 4.3 grams, okay, when terms cancel out. That's how much AgCl you produce if, again, calcium chloride was limiting. Now, 4.3 is a larger number than 2.9, so therefore, silver nitrate should be limiting. And therefore, the amount of silver chloride that you produce is 2.9 grams of silver chloride, not 4.3. Okay. Now, you're asked here also for the concentration of ions. Now, you should know that even though silver nitrate is the limiting reagent, the only active part, or the only ion there in silver nitrate in the formula, which should be responsible in the formation of silver chloride, should be the ion silver, or the silver ion. Okay, nitrate, even though again it's part of the salt, does not really participate in the reaction. It is one of our spectator ions. Okay, so let's consider the net ionic equation. Again, this is the actual reaction which happens in order for you to form silver chloride. NO3, the nitrate ion, is just a spectator. Okay, another spectator too will be calcium from calcium chloride. So again, these two are just spectator ions. Okay, so first we want to know what their concentrations are. Or, well, I think we're only asked for number of moles. No, we're asked for concentrations. Okay, so again, these are spectator ions. Okay, now we can get the concentration of calcium 2 plus in nitrate from the number of moles, from first determining the number of moles of calcium and nitrate from the silver nitrate and calcium chloride solutions. Okay, so let's do first nitrates because we worked first with silver nitrate anyway. Okay, so we have a number of moles already for silver nitrate. Okay, we've actually calculated it already here. Okay, we've not written it out though, but for this one, the concentration of silver the number of moles of silver nitrate, remember, it fully dissociates in solution, should also be equal to the number of moles of silver plus in solution. Okay, and that should also be equal to the number of nitrate ions in solution. Okay, which will just be 0.1000 liters times 0.20 moles per liter. Okay, so both of these, silver and nitrate, originally there's 0.020 moles. Okay, now silver, since silver nitrate is the limiting reagent, is fully consumed. Okay, so the concentration actually of silver in at the end of the reaction should be 0. Now for nitrate, these 0.20 moles of nitrate are not going to participate in the reaction at all. So this should be the moles of nitrate. Okay, now to determine its molarity, we are not going to use the volume 100 liters just because we have a new volume of the solution. The volume of the solution now, I think it doesn't say assume that the volumes are additive, but let's just assume that they're additive. The volumes of the solution should be 100 plus 100 ml, 200 ml. So for the concentration of nitrate, Okay, the concentration of nitrate ions should therefore be 0.020 moles. Okay, and then divided by the total volume, which is 0.200 liters. Okay, or 0.2 thousand liters actually, if we observe sig figs. And then this should just give you 0.075 molar of NO3 minus. Oops. So again, just remember that this is how much nitrate has not reacted. Okay, that's the concentration of the nitrate. Even though the volume has changed, the number of moles of nitrate has still stayed the same. So, but the concentration is what we're actually looking for. So the concentration here should just be 0.075. None of the nitrates have reacted. Now for the concentration of silver plus, that should be 0 because all of the silver plus ions have been converted into silver chloride. And silver chloride is an insoluble salt. Okay, let's go next with calcium. Okay, so for calcium, we can derive that from calcium chloride. Okay, the number of moles of calcium chloride, okay, should be equal to the number of moles of calcium 2 plus. Okay, and that should be equal to 1/2, okay, of the concentration of sodium, or sorry, moles of chloride ions. Okay, so this one will be the relationship between these. So here, let's take this part first. Okay, so if we take this part, the number of moles of calcium chloride is again so NaClCaCl2 is equal to 0.1 thousand liters times 0.15 moles per liter. Okay, so that one should give you 0.015 moles. Okay, 0.015 moles. Now that is again equal to also the moles of calcium 2 plus. Okay, so therefore the molarity of calcium 2 plus, okay, which has not participated in any reaction, should just be 0.015 moles. Sorry for the stray marks. Okay, and then divided by 0.2 thousand liters. Okay, the new volume of the solution, and this one will just give you 0.075 molar. Okay, that's basically the concentration of calcium 2 plus. Okay, now let's focus, or let's turn our focus on this part of this equation. So according to this one, the number of moles of calcium chloride is half the number of moles of chloride ions. Or another way to actually say this is the number of moles of chloride ions is equal to twice the number of moles of calcium chloride. And you're probably more familiar of this one than the other one here on the left. Okay, so basically here, to determine the number of moles of chloride ions, that should just be this number, okay, 0.015 times 2 times 0.015 moles, okay, and that should give you a total of the moles of sodium chloride, or sorry, chloride will just be 0.030 moles. Now these are the number of moles of chloride in total, reacted and unreacted, okay. And in the problem, what we actually want to determine will be how much is the concentration of chloride is left after the reaction has proceeded. Okay, for that we have to turn our attention again to the net ionic equation. Okay, but let's write that down on another slide. Okay, so the net ionic equation again is silver plus aqueous plus chlorine minus aqueous, okay, going to silver chloride. Okay. Note that we have calculated already silver plus ions. So this one we have mentioned earlier is 0.020 moles. Okay. And for chloride ions, this is 0.030 moles. Okay. Now again, silver is the limiting reagent. Okay. And as you can see, you can set up a dimensional analysis equation for this one to figure out how much moles of chloride do you need if silver plus was the limiting reagent. Okay, so you can set up something like this: 1 mole of silver plus 1 mole of chloride ions, and it will just cancel out and give you the same number. Okay, but basically this is how much moles of chloride will react with silver plus, which is the limiting reagent. Again, we didn't have to really do this, but this is, if you remember, the second approach at trying to determine what the limiting reagent is. Well, sorta kinda, because at this point we've determined already what the limiting reagent is. So okay, if 0.02 moles of silver, or sorry, if chloride reacts with silver, then we will have 0.030 minus 0.020, that will be equal to 0.010 moles of chloride left unreacted. Okay, and then to solve for concentration, you just again divide this value by the total volume of the new solution. So molarity of chloride ions is equal to 0.010 moles of chloride divided by 0.2000 liters, and that will give you this time 0.050 molar of, again, unreacted chloride ions. All right.